I would like to introduce Pooja Jain from Intel and King Sum Chow from Alibaba Inc. And they're here to present to us today cultivating software quality in the cloud via load testing tools. So please help me welcome them.
Well, thank you. Well, I can see a lot of you are still awake for the last session before the last keynote. Thank you for staying up here. And I certainly hope that this will be a good use of your time here. So why am I presenting a talk from Alibaba with Intel? I think some of you have that questions. The answer is pretty simple. I used to work at Intel. So I submitted the abstract while being an Intel employee with Pooja. And then I changed my mind. I say, well, let me try another company. So a few months ago, I had a chance to move to Alibaba and work at there. But I continue to finish the work with Pooja here. So we're going to talk about the work we're doing here. And I'm going to slightly diverge into the work is still valid at some internet companies like Alibaba. So let me get started. Well, this is the this presentation was prepared with a few other authors. Right now, just Pooja and me are here. So what's the problem we are trying to solve when we say load testing software application in the cloud? So some of you might have used some cloud services, and you might have put some application on cloud services. So that is one aspect of using the cloud services. So you put up some app in the cloud, and you want to figure out what the app can handle. Within that space, there are probably multiple scenarios you're looking at. For example, you might be looking at you put up a small instance running in some cloud like Amazon Cloud, or in the case of Alibaba, Ali Cloud, right? You put up some small instance. You want to test things out, how things are going. And you may choose to put up on a bigger instance, and you want to check out things, are they doing right? Some of you might be doing something different. Maybe you have a large data center, and you want to test out the application running in the data center that you have more control. So you are not just a cloud customer. You can think of yourself as running something like a private cloud. You can see a little bit more things. So today we're going to talk about the latter case, when you can see more things, what kind of load testing method you can apply so that you can figure out how your app is doing. In particular, there are two aspects. What is the maximum capacity your app can do in a cloud environment? So given an instance you're running in a cloud, in our case, we're talking about private cloud, and what kind of capacity it can perform. And the second thing we're going to talk about is, if it does not perform to the capacity you want, what kind of analysis we can do, what kind of data we can collect, and so that we can analyze the situation. So those are the two things we are going to share with you today. So that is what brings up to software quality in the cloud. So just like what I mentioned earlier, we have some kind of application we are running in the cloud. We can pick up some load testing tools to see what is the capacity it can sustain in the environment. Some free and available tools are JMeter and Pavin. We're going to talk a little bit about these two tools. Of course, these two are not the only two tools. You guys might be using some tools. Maybe those are the tools that are endorsed by companies. Those are great tools as well. There are some tools that cost a few dollars. Yeah, those are great tools as well. But I try to be cheap, so I stay with things that are free. That's all. Okay. So you run some load testing tools, and you drive your application. You want to see how much you can do. Your application most likely can generate some kind of events like, I'm processing this transaction, I'm doing this, I'm doing that. Oh, I need to do a garbage collection, if it is a Java application. So it's going to emit some information for you to analyze, and hopefully it can help you to figure out things. Whether you're running in the cloud or in a regular Linux environment, the operating system will generate some data for you, right? If you are a public cloud customer, then you may not be able to see some of this depending on your providers. But if you are inside a private cloud, yes, you can get all this data because you're inside the environment. And these data can come in very handy. And later on, we're going to show a case study how this data can help you processing the performance of your application. And then the next lower level is for some of you, if you're lucky enough, you need to make some purchase decision in your data center. You need to figure out what is the next generation platform to buy. And then you want to drill down to the hardware level. If you're lucky enough to do that, we have a method to collect the data using something called perf running on Linux. And we can drill down to the CPU performance counters. But due to the limitation in time, we are not going to showcase a case study here today. But if you have questions or you want to share your experience with us, we're happy to talk about it offline. So these are the 4 layers of software. Well, you may say, well, what is that? That is, we are not doing anything specific to any cloud. That's true, because we want to talk about a technology that is probably relevant regardless of what kind of cloud providers you're using. So moving on to the next slide. For the customer experience, for the user experience data, we are going to focus on only 2 things today. We're going to say that, well, you set up an application. Let's say you set up something like a website, you're selling some fancy shoes online. So you want to figure out how many transactions you can handle within a certain time. So that is throughput. So throughput just means that for most of the applications we deal with, we have some way to measure how much work is being done that is useful for the users. So in some cases, you could be a web transaction, and you could be just completing some internal batch transactions, and you can be completing a number of database queries. So we have some way to measure the quality in terms of throughput. But throughput just describes how much work is being done on the system. It doesn't. So a system doing a high number of throughput does not do the user any good if it takes a long time to process the request. So the other metric that we care a lot about is the response time. How fast does the application respond to a user request? So we track that as well. There are different ways the response time is tracked. There are many tools, like, for example, if you're running with JMeter, they measure the response time from the time you send a request to some kind of application running in the cloud until the time it comes back. There are also other definitions. For example, some definitions used by Google, they use the latency within the application server. But regardless of that definition you use, you have some way to measure the responsiveness of the applications. So that brings up to the next thing. So far we have talked about we need to estimate the performance of the software application. And we talk about there are a few metrics we care about from the user's point of view. But when we run the test, we don't just want to figure out from the user's point of view what's happening. We want to see, well, if something is not quite right, can we figure out what causes it, and can we figure out how to fix it? So while we are doing the load testing, we are collecting a fair amount of data. You can think of us as, in addition to load testing tool like JMeter, we collect data on the app server and the load generator. So for all the machines that participate in the load testing test, we will collect the hardware resource utilization data. We pick up the CPU, the memory. The consequence of doing that is I need to launch a lot of agents to drive the load, because each agent will send a request, get a response, and think for a few seconds. A few seconds is a really long time on the computer. So in order to saturate the computer, you add a lot more agents. When you add a lot more agents, that means for most tools like JMeter and Pavin, they launch additional software threads on the driver. So that will cause some stress on the driver. And if you want to do a quick test and you try to avoid using a lot of agents, one thing to do is to use zero think time. It's not the best choice if you want to mimic the user behavior, but if you want to get a pretty good estimate about where things are, zero think time will reduce the overhead on the load generator. and it's helpful to do. So we talk about some of the criteria we're making about. We want to assess the quality of the software through throughput and response time. And we want to make sure that it can be easily done by considering the use of zero think time. It's not an ideal solution, but it cut down the resource consumption on the load generator. And we collect the system performance data through various tools. So let's talk about the two tools that we mentioned today. And we started using Pavin. The reason we started doing that is Pavin is the load driver used by a lot of the benchmarks that are used in the SPEC committee. The SPEC consortium stands for, I forgot what it stands for, but it's called some Standard Performance Engineering Consortium, probably right. So they design a bunch of benchmarks so you can run and test how fast your software is running or how fast your hardware is running. And many of the benchmarks are driven by Pavin, so it has a good collection of statistics like throughput, response time, mixture, and things like that we mentioned. It turns out that it is a little bit hard for me to get to the specific HTTP request using Pavin. It's not built for it's not built for us. Then we set up a web page and we try to figure out the usage pattern, and then we put these requests there. So the user interface is not the best for that. So we look around and find another tool, which some of you might have used, the Apache JMeter. We're not saying Apache JMeter is the best tool. You just say that. It just happened that it seems to do our job pretty well, and we encounter a few issues with a few things, but overall, it does a pretty good job. So it enables us to access a website through the predefined URLs. You run the sequence URLs, you can do mixtures, and you can do different things. And it generates throughput and response time. So you can compute the response time in different ways. By default, it comes up with one way to compute the response time, but if you want to compute a different way, you can do that as well. So far we have talked about, we have an approach, we want to access application performance in the cloud. We have some criteria and some metrics to use, and we have some open source tools that can help us to do the work. And we also talk about, but we have not shown you, that we can collect the data at the server, at the software performance at the server, with some of the data that might be useful. And with this, Pooja is going to talk a little bit about the methodology and the case study. Thank you.
Thank you, Kingsam. That was a great introduction. Moving forward, we'll be talking about first the design of the load testing tool, the generic flow of any load testing tool, how it works. To start off with, as Kingsam mentioned about the goals, first we need to define when we start an experiment, like what are the use cases that you want to test. Secondly, moving forward, if you want to use a think time of 0 or any other number. And so you need to design your experiment and configure it. And once you've done that, you start the experiment, that is, initiate the request. So in the configuration, you would also mention the amount of load that you want to stress your system with. So once you initiate the request, the load is slightly like a ramp up phase happens, and then steady state takes place, and then a ramp down phase. So you increase the load gradually and stress the system out for a period of time, and wait. Monitor the system for a steady period of time, and then record the performance data. So once you send out the request to the server, you wait for the response from the server, and while all this is happening, supposingly you give a load of 10 users and a ramp up time of 5 seconds. So every 1 second, 2 users are ramped up. And then that means you're having 10 agents, as Kingston mentioned, that those are the user threads that are sending in requests to the server. And then apart from that, you have another thread, that is the 11th thread, that is monitoring all this activity, that is monitoring the data, like how many requests are being sent to the server, at what rate they are sent, and what is the rate at which we are receiving the response, what is the size of the response. All this monitoring thread is looking after all that. And meanwhile it is doing all this, it is recording all these responses, generating stats. And you can usually, most of the load testing tools have a GUI that will generate the real-time graphs, and you can monitor your real-time performance of your application about how it is behaving. At the end of the experiment, it gives out the report, a summary report, as well as a detailed report. So once you look at all that stuff, you can redesign your experiment and repeat the whole process. So this is a general way in which a load testing tool works. So now that we have discussed several things about the configuration, the flow, the goals, we can now look into a three-step methodology that we are using to cultivate software quality in cloud. So starting off with first determining the saturation point. As we are gradually increasing the load from 0, like 1, 2, or 3, or 5 users, we look, not necessarily you have to start with 1 user, depends upon how your application behaves. Supposingly you're using in this case, I'm just talking about imagine you've deployed your application in cloud and you don't know what the hardware resources you're having. So you start off with a very minimal load and gradually increase it and see what is the maximum load that you can achieve. So determining the saturation point, moving forward, then we are correlating the performance data. So as in our experiments, we are using the private cloud. So we were fortunate enough to get the SAR data, the system data, the data at different levels. So we have data at load testing tool, the data from load testing tools. We have data from the system, from the client side, from the server side, and we also have the data from the application logs. So once we have all the data, we could correlate the data and see, look into the details. Further, once we look into the details, definitely we can see what is causing the scaling issues, and we could identify some software solutions by talking to the experts. So once you have done that, definitely the experts would have a lot of experience. Even by looking at the data, you would get an insight about where is the pain point, and you could then once you identify a problem, you will definitely move forward towards the solution. So and then this is a closed loop, and then you keep continuing this until you find a proper stable application. So this is a 3-step process. We can further explain it through a small example. So in this case, first we are this is just generated data. It's not a data from any application, but it's some data that I just put in together to explain this concept. So further, firstly starting off with 100 users, we see a seat utilization of 30% and a throughput of 50 with a network bandwidth of 400 megabytes per second and a response time of 0.2. So, and then this looks good. So we further increase the load. We double the load to 200. And then we again look at the data. It is 60% CPU utilization, and throughput goes up to 100. Well, it's scaling very well. And then further you increase the load, and then you look at this. Okay, supposingly you wouldn't have collected system performance data, you look only at load testing data and the application monitoring data, and you realize that there is something off, but you'd never know what is causing the scaling issue. Is it the CPU, network? So just collecting the data from all the perspectives gives us a sneak peek into the what's happening behind the scenes, and we can pick up on where we could improve a solution. So this is the basic this is a very high level 3 phases that I'm talking about. There are a lot of sub-steps that goes behind in it. And so let's understand all this as we apply this to our case study, and let's talk about it first further. So I'm going to talk about an application called Ticket Monster. So you all must have some or the other time always go to some or the other website to look for your concerts or book of any game that is happening around you. So this application is mimicking such an online application. It is actually a real application. You can always go on to www.ticketmonster.com and always see something like this. So we are mimicking this on our cloud. We have downloaded this application that is open source available. And this is designed on JBoss. So we have deployed it using JBoss application server. And we are using think time of 0. And we are driving the load using JMeter load testing tool. So, and so this is our setup basically. And we are So first, starting off with our process, the first step is determining the saturation point. So as I mentioned, we'll have to first figure out what is the where is our performance not increasing, where is it staying stagnant. So so in this graph, you can see the x-axis is the load, 0 user, 1, 2, 3, 4, and 5, and y-axis is the overall throughput. The throughput here is measured about operations per second. In our case, we are just sending one request, like getting the events, finding what are the current events that are around your city at this present point in time. So continuously with 0 think time at one user, the request is being sent. And as you can see, with one user, we are able to reach up to 420 operations per second. As we increase the load, it further scales up. And after 3, 4, and 5, it looks like it kind of plateaus. It does not increase further, but the response time seems to increase. Well, also don't, okay. So so now we need to figure out why is the scaling issue. That is something we want to figure out. Okay, moving forward. So next is correlating performance data. While conducting these experiments, we have collected data from all the different levels that we mentioned earlier. So we are looking at the data right here. This is from the server side, and we are looking at the system data that is collected using SAR, and we are looking at the CPU utilization. It goes up to about 60 to 80, and it stays there and doesn't increase further. Well, this is average. Well, this is average CPU utilization during one experiment, and each of them corresponds to one experiment exclusively. So one experiment was conducted with only one user, another experiment when the load is of 2 users, and so forth, so on and so forth. So we are comparing data of. Next, we are comparing the system logs from system data from the client side, and we are looking at the transmitted KB per second. This is the network data that this corresponds to the response received. So when I send in a request and I ask the server for what are the events that are around the city, then it sends in the response, and the size of your response is being recorded here. So this is transmitted KB per second. So we see this data. This corresponds. Yeah. And this seems to be in sync with what we have seen so far. So after 3 users, it also kind of plateaus. The CPU utilization also kind of plateaus, and even the throughput. So finally, we look at the application logs. The application logs on the server side. Since this application is running using JMeter and it's deployed using JBoss, the application server especially is deployed using JBoss and is running over Java. We are looking at the GC logs. So how many of you are aware of garbage collection in JVM? Yes, right. So, yeah. So the garbage collection is like the maintenance time the JVM is taking for clearing the objects. So here we are plotting the number of the frequency, the number of times the GC occurs during an experiment when the load is of 5, 4, 3, 2, 1. So we observe that after 3, that there is a high frequency of GC. And this is like, we are running about this experiment for about 500 to 600 seconds, like about 540 seconds. And every second we incur a GC. So this looks like we are reaching some kind, there is some problem that we are facing here. After talking to experts and all, we can see that maybe we should try by reducing the frequency of garbage collection. So if someone is not aware of garbage collection, when garbage collection occurs, the other threads are not allowed to do anything. It's like a maintenance space. So the server is down and you're not supposed to work, and the objects are getting cleaned. So when garbage collection is occurring, and the application server is actually not doing any work. So moving forward, we realize that, so now we are looking the data from the application side, system data on server and client, and now we also looked at application data at server logs. By looking at the data from all perspectives, we could see that there is some anomaly, and there is something that we can fix. So after talking to the experts, we thought that we could increase the garbage collection heap size. The heap size is nothing but like a RAM for Java, for the JVM. So we increased the heap size from 1. Initially, we were using 1 GB heap size, so we've increased from 1 GB to 2 GB and see what the performance looks like. And we definitely see some improvement in performance. We see about from 880 operations per second to we see an improvement up to about 950 or 950 operations per second. So, well, and this comparison is only for 5 users. Obviously, it improves for all the users, but for ease of understanding, I've just put up here for both 5 users with a heap size of 1 GB and 2 GB, and the response time actually remains the same. It does not increase, even though the throughput has increased, but the response time has not. So it says that the time that was spent in doing garbage collection, it's actually doing more work now and not spending time in GC, and that's why we are able to get more of throughput. So let's get this into a perspective. Now you might be thinking that this is a very small improvement. Think about it as this is deployed in a container, and one container was doing about 880 operations per second. And now you want to be able to do your application must be able to serve 1 million requests per second. In that case, when you see the number of containers you would need for 880, when your application is able to serve 880 operations per second, with opposed to when your application is able to serve about 950 operations per second. If you do the math, it's about 70 to 80 containers that you're saving. So you will be saving a lot on that, right? So even if you do a slight improvement, if you're into marketing, that would be a big number. Yeah.
How long did you run your load test?
It's only for 540 seconds. Yeah.
Is it the same for all the users?
Yes. Right. So we thought of doing some more optimization, and we do a second iteration by going through all the data in details this time, and not just looking at the average. So we first look at the CPU utilization data for the 5 users, 1, 2, 3, 4, and 5. And the x-axis here says the seconds. So each 1, 6, this would be like, this is an interval of 5 seconds. So, and this corresponds to the CPU utilization. The different colors say the users. So, well, yeah, it's a pretty. So next we look at the received KB. This is from this the driver side, the data, the received KB, because apparently the way we have designed the JMeter, we do not have the time series data for our request, like the number of throughput that we are getting per request. We do not have the data currently, but we do have the SAR data, that is the system data on the client side, which corresponds to the received kilobytes per second, the network data, which would correspond to the amount of requests that we are receiving over time. So now we are correlating system data on server and on client, and looks like these all the user threads. For the first one, it kind of goes up high. After a while, it comes down, and it's using only about 50% CPU utilization, and fine, the experiment ends. For the second case, it goes all the way up. It's almost saturating. It's going up to 100 and goes down, and it's kind of same for all of them. But what's interesting is looking at the in network data. This is a ramp. It looks like this is the ramp up phase. It kind of saturates. Suddenly it drops down. I don't know what's happening here, and it goes up and so forth. So as we've seen in our first slide, the throughput, this corresponds to the throughput for 2 users, 3 users, and after, 1 user, 2 user, and after that it remains about the same for 3, 4, and 5. Well, this is in sync with what we have seen. So now what we see here is just by looking at the details of the data, only by just we usually use R or Python for doing data analysis, but this one is like a simple Excel graph. Even just by looking through Excel and just plotting some graphs, we are able to visually see some anomalies that you would have seen, that there is a dip here and there is a dip there. What could have caused these dips? The first one looks like the system is getting prepared, and now it's waiting for the request, because this is on the server side. The system is getting prepared, and now we are waiting for the request to come in. There are no requests in, and as soon as it is receiving the request, it is starting to do the work, and the utilization seems fine, and it goes down. Oh, well, this looks good. How about this? This seems to be doing work, and then we have a dip in here. What could be causing the dip here?
Is that a GC pass?
Can it be for that long? And we are having GC for like, we saw GC for like 500 times, right? We don't see that kind of a dip 500 times. Maybe if you said this is a GC pause, maybe we could think about that. How about this? Like, and yes, this was really stunning until I saw this. I was like, what is going on with the data here? And after looking at all the details, and so usually we can run PS, stop, and stuff to see what all the other processes that are running at any given point of time. So we are at Intel, we have a bunch of automation scripts that we actually use whenever we run any experiment. Whenever we try to characterize any workload, we just put in that automation script and we run it. So in those bunch of automation scripts, we have we are collecting a bunch of data collection. We start a bunch of data collection tools which run for a certain period of time and stop. So at this particular time, there was one particular tool that I cannot mention right now. So that was started and that had stopped. So looking at our script, we were like speculating this is the only thing apart from that's the only thing that's running which is different from all the other time in the run. And that was our speculation. And when we discussed with our team members who are very well experienced, they said this cannot happen because that performance tool we've been using for ages and it has always worked. So obviously performance tools have a lot of very few, like a lot of overhead, and some of them have a lesser overhead, but this tool has very little overhead, like about 1%, we would say. But in this case, it doesn't seem to be so this was just a speculation, and we made the test. We made the run again without the tool, and we see that, well, okay, this is with and without the tool. We see the CPU utilization. Again, this is for 5 users. Both of them are for 5 users, and one is with tool and without the tool. And it seems like the CPU is saturating on both. But okay, fine. But when we come on this side, in one case, well, we see the dip as we saw in the previous graph. So it looks like if you just see the CPU side data and only on the server side, it looks like, okay, you're doing the work, but maybe you're not doing the real work. You're doing something else in there. So by looking at this data, we figured out that without the tool, yes, we see an increase in the throughput, and with the tool, there was a dip. So finally, I do not say that we found a solution, but because we still have to figure out why that tool was particularly not working in this case. We're still working on that, but at least we could figure out that is the problem by looking at all the detailed data and looking at the data from different sides. So once you can find out what is actually causing the problem, then that will lead you to the next steps to find out different solutions. So maybe you can find an alternative performance tool instead of that, or you could figure out why actually, or maybe the configuration, maybe it was running with this application, or it could be Intel hardware. I wouldn't say that because we are actually, our team actually works with different hardware that keeps coming in and out, and we keep testing on new hardware, so that could that could also be one of the cases. So we are looking into what could be the issue at this point. So, well, that is my case study. So the things we want to take home today are that discover the performance issue with the load testing tools by collecting additional add-on data along with your load testing tools. First, you saturate the load, and then you will be able to see the issues. Next, correlate the performance data. And third one, identify the solutions along with your experts. So by this, I'd like to conclude my talk. If Kingsam, if you want to add something, that would be great. Thank you, guys. Any questions? Yes.
You took an open source approach.
Yes.
Why? Okay, so for example, there's other tools out there like Dynatrace that do very similar things and give you actually maybe more visibility and there's less configuration. Is there a reason why you chose this approach versus say just a third-party tool that allows you to do these kinds of things?
When I can get almost all the data that I would get with a commercial tool, why will I not go with an open source tool? Also, we have the add-on tools to look at the data, like we have the other, like just as I mentioned, as we have SAR, perf, and other data monitoring tools, performance monitoring tools. When we have all that in handy, I think we wouldn't need commercial tools. We used to run LoadRunner initially, but then later it became it became commercial, so we switched to Pavin, and then now we are testing with JMeter to see how it goes. Yeah. Yes.
Are you running this all on hardware, or is any of it virtualized?
Yes, we have instances of this in virtual machines, and we also have instance of this on a private cloud. Yes. But yeah, this one is kind of a virtual environment you can think of. Yep. Yeah, sir.
Do you have control over other things that are running on that same host, or does that enter into your decisions on the VM?
So you're talking about the neighbor issues, right? Noisy neighbor problems.
Yeah.
Well, yes. Since this is in our private cloud, yes, we have control over that. But apart from that, if we would have been running it in a public cloud, we might not have control. So at present, if I'm running on that, I just say that, okay, I'm using that system. So if it goes like, right, yeah. Any other questions? All right. Okay, thank you guys. Thanks for staying so late.